What's up, guys? So today we're going to be adding and subtracting rational expressions. And before we do that, we're going to practice adding and subtracting fractions. So suppose you've got 1/2 plus 2/3. Real simple one, right? Do you remember what to do here? First thing you have to do is you have to get a common denominator. Adding and subtracting fractions, in my opinion, is actually harder than multiplying fractions. Because if we were multiplying, you would just do the top times the top, the bottom times the bottom, and that's what you get. When we're adding and subtracting, we have to have a common denominator. So a common denominator for 2 and 3 would be their least common multiple. The least common multiple of 2 and 3 is 6. So we know we're going to get something with 6 at the bottom. Now how do we get 6 at the bottom? What would I multiply 2 by to get 6? To make that 2 into a 6, I'd have to multiply it by 3. So I'm going to multiply this fraction by 3 over 3. And the 3 I need to multiply by 2. So if I multiply this by 2 over 2, that would be 3 over 6 plus 4 over 6. And now that you have a common denominator, you can say, well, the 6, we've got 3 6 plus 4 6. So altogether we have 7 6. Okay, that's how it works with numbers. So what happens when you start throwing an x in there? Well, that's what's called a rational expression. A rational expression has an x in the denominator. So maybe you've got something like this. We'll do a simple example first. 1 over x plus 1 over 3x. Okay, so having an x in the denominator makes it a rational expression, and so this would be adding rational expressions. So to add these together, we have to get a common denominator. What's the least common multiple of x and 3x? So it turns out 3x is the least common multiple. If I just multiply this by 3, I can make 3x over here. So I'm going to multiply this side by 3. So that's going to give me 3 over 3x plus 1 over 3x. Now that I've got a common denominator, I can just add the top. 3 plus 1 is 4 over 3x. Okay, so continuing to get a little bit harder, let's check out another example. What if I say 2 over x plus 4 over x plus 1? What's the least common multiple of x and x plus 1? Unlike before, see, I could just multiply this x by 3 and I'd get 3x on both denominators. I can't just add a 1 here. All I can really do is multiply or divide. So I can't multiply x by something that's going to give me x plus 1 and vice versa. So like we did with the 2 and 3, we've got to use the least common multiple. And a lot of times your least common multiple is going to be the product of those two denominators. So in other words, my least common multiple is going to be x times x plus 1. So that's the denominator that I'm going to be shooting for, x times x plus 1. Well, to get that, on the left side, and I don't really have a lot of room to write this out, so just kind of bear with me here. I've got to multiply this fraction by x plus 1 on the top and bottom. And I've got to multiply this fraction by x on the top and bottom. Okay? So what am I going to get? If I multiply the left by x plus 1, that's going to be 2 times x plus 1 over x times x plus 1. Let's take this and multiply top and bottom by x plus 1. And over here I got to multiply by x. So you're going to get 4x over x times x plus 1. Remember the denominator, we already know it. We don't need to do anything. We know what that's going to be. It's the product of these two. Now, I would definitely leave the denominators factored, and we'll explain why later, but that you definitely want to leave these factored. However, on the top, sorry, my video stopped out there for a minute. On the bottom, we want to leave these factored, but on the top, we need to go ahead and multiply these out so that we can combine the like terms, okay? So we're going to say on the top, this is 2x plus 2, we distribute, over x times x plus 1 plus 4x over x times x plus 1. And now one more step, we need to go ahead and add the top of these fractions and combine the like terms. 2x and 4x makes 6x. And on the bottom, you simply have x times x plus 1. Oh, sorry, we're not done. 4x and 2x make 6x plus 2. Don't forget the 2 here. 2x plus 4x is 6x. And then bring down the 2. Okay, so here we have another example. Notice that the denominators are x plus 2 and x squared minus 4. Now, x squared minus 4 is factorable. And when you see that, you should make sure that you go through and factor that, because while you could multiply each fraction by the other denominator, and that would give you a common denominator, you're going to get one that's much bigger than you need, and then you're going to have to reduce. So instead of doing that, go ahead and factor any of them that are factorable. X squared minus 4 is actually, I'm going to cross this out, that's actually x plus 2, x minus 2. And if you don't remember that, then you need to go back to our unit on factoring. This is why that first unit when we did factoring is so important. We're using it throughout this course. So now that we have this rewritten, okay, notice that both factors have an x plus 2. So all we need over here is another x minus 2. So if I multiply this fraction by x minus 2 on the top and bottom, we'll have the same denominator. Okay, so I'm just going to multiply by x minus 2 on the top and bottom over here. Okay, now what is that going to give me? Well, on the bottom, we already know the denominator is going to be x plus 2, x minus 2. On the top, you're going to have to do some multiplication. X minus 2 times 2x plus 3. Use the box if you need to do that. However you need to multiply these together. But that's going to be 2x to the, 2x squared plus 3x minus 4x. So minus x and minus 6. Now on this side, we've already got the common denominator. And since we have a common denominator now, all we have to do is combine the like terms on the top. So the negative 6 and the 5 we're going to combine, and we're going to get 2x squared minus x minus 1 over x plus 2, x minus 2. Now before we call it quits on this problem, we need to make sure that nothing here can be reduced. And so what we need to do is we need to factor this if it's factorable. So always take the time. If you see something that looks like it might be factorable, you should always check to see if it is. And let's just see, are there two numbers that multiply to make negative 2 that add up to make negative 1? Let's go to the side here. If I was factoring this, a times c would be negative 2, b would be negative 1. Are there two numbers m and n which multiply to make negative 2 and add up to make negative 1? How about negative 2 and positive 1? They multiply to make negative 2, they add up to make negative 1. So we can factor using my box method. 2x squared, put these in the middle term, minus 2x, x, and then bring the negative 1 down. Pull out the greatest common factor in each row. 2x, this would leave x and minus 1. If I pull an x out, it would leave 1, and check that 1 times negative 1 is negative 1. So this factors as x minus 1 and 2x plus 1. And so now we need to look at it. Does anything on the top cancel out with anything on the bottom? And in this case, it doesn't. But we really needed to factor anyway just to make sure that it didn't. Okay, so here's one final example. Now this one looks harder than the ones you've seen before, but actually you're going to see it's not that bad. So when you see things like this that look like they might be factorable, you should always try to factor them on the numerator and the denominator. On the numerator, are there two numbers that multiply to make 4 that add up to make 5? Because remember, if a is 1, these are easy to factor. There is 4 and 1. 4 times 1 makes 4, and 4 plus 1 makes 5. So I'm going to factor the top as x plus 4, x plus 1. And in the denominator, two numbers that multiply to make negative 8 that add up to make 2. That would be positive 4 and negative 2. They multiply to make negative 8, and they add up to make positive 2. And then we have to rewrite the other fraction. Now if you notice, are there some things on the top that cancel with some things on the bottom? And you can only look within the same fraction. So in here and look in here, we can't cross this way when we're adding anyways. There's an x plus 4 and an x plus 4 that cancels. Now actually what we're left with, if you look in the denominators, we have a common denominator now. So I can add these together, and that's going to give me, I can add the x, or I'm sorry, I can add the 1 and the 3, so I'm going to get x plus 4 over x minus 2.